Liskov Substitution Principle. The Liskov Substitution Principle states that an instance of a subclass should be able to replace an instance of its superclass without breaking your program. For example, we have a method called enroll that has a student object as a parameter. We should be able to replace the student object with an instance of part-time student, a subclass of student. You might think, this sounds obvious. Why wouldn't we be able to do that? If we don't follow the Liskov substitution principle when writing the part-time student class, replacing this with this will break the program. How can that happen? Here's a few examples. If x.method1 originally updated a variable, but it doesn't anymore in the subclass, your program might produce the wrong output. If x now accesses a file outside of your program, but did not do that before, x.method1 might throw an exception that the rest of the program does not handle and therefore will crash. If x.method1 used to return an object every time, but now returns null sometimes, this could cause a null pointer exception when the rest of the program tries to access the return value. In general, when making decisions about a new subclass, the Liskov substitution principle invites you to include at least the side effects that are similar to the superclass methods and exclude anything that might require changes to the existing code in other classes.